Okay, so now let's move on to question number 2. Question 2, what is the Lewis structure of Ni3? So nitrogen triiodide. Okay, so to write the Lewis structure, I first want to find the total valence electrons of the compound. So for nitrogen, nitrogen has 5 valence electrons. And for iodine, each iodine atom has 7 valence electrons, but since there are 3 of them, I'm going to multiply by 3. So I get 21. And then adding these two values up, you get a total number of 26 valence electrons in the compound. Okay, so now let's draw our nitrogen in the middle and a single bond to each of the iodines. And then now I'm going to draw all of the lone pairs on iodine. 1, 2, 3, 4, 5, 6. Okay, so after I write all the lone pairs on all of the terminal atoms, I like to count how many I have so far at this step. So each bond contains 2 electrons. So we have 3 bonds, so that is 6. And then I'm going to count out all of the lone pairs. So each of the iodines has 6 lone pairs. So 8 times 3, I have 24 drawn so far. And the remaining 2 I can draw as a lone pair on our nitrogen. Okay, so that gives us 26 valence electrons. Nitrogen has a full octet, so I can say that this is the Lewis structure for Ni3. Okay, so let's see what the junior tutor said. Lewis dot structure is a representation of an atom, ion, or compound that shows how the valence electrons of the atoms are distributed as bonds, lone pairs, and sometimes radicals. Drawing the Lewis structure of a compound may sometimes need some trial and error. However, we can follow some guides and rules in drawing it. Okay, so they have a step-by-step guide. Determine the central atom, so in our case it was the nitrogen. 2, logically arrange the atoms. So this is when I placed all the 3 iodines. Thinking beforehand how many bonds an atom can create can be helpful. For atoms that follow the octet rule, the number of bonds an atom typically makes can be solved by subtracting 8 by the number of valence electrons of an atom. Yep, so that's one way to do it as well. Then you connect the atoms, adjust the number of bonds if necessary. 4, check if the rules below are followed. If not, make the necessary adjustments. 5, redraw the entire molecule if needed. So the rules. Make sure atoms that follow the octet rules strictly have 8 valence electrons. These are typically period 2 nonmetals. 2, minimize the formal charges of the atoms if possible. 3, more electronegative atoms are given the more negative formal charge if applicable. 4, make sure the sum of the formal charges matches the charge of the compound. Okay, so using these guides, they drew Ni3. The most logical central atom is nitrogen, since if it were a side group, it would be difficult to satisfy the octet rule for nitrogen. Step 2, the arrangement would be to simply place the 3 iodine atoms around nitrogen. 3, when a halogen such as iodine is not the central atom, typically follows the octet rule. Thus, to achieve the octet state, iodine, which has 7 valence electrons, would usually create one bond only. On the other hand, nitrogen, which has 5 valence electrons, would need to create 3 bonds to achieve the octet state with a 0 formal charge. Based on these, the total number of bonds the 3 iodine atoms need matches the number of bonds the nitrogen atom needs. To complete the Lewis structure, we just have to add the appropriate number of lone pairs to ultimately place 8 valence electrons to each atom. Okay, so they got the same Lewis structure I had as well. For the last step, let us verify whether the rules were followed. Okay, so they made sure of that. And they also showed the formula for formal charge. So all of the atoms had a formal charge of 0, so that was good. If we solve for the formal charge of each atom, we would see that they all have a 0 formal charge. Rule 3, more electronegative atoms are given the more negative formal charge, so that is not applicable in our case. And the net charge of our compound is 0, which matches the sum of the formal charge of the atoms. Yep, so the solution is correct. Spell.